Hello, dear students and parents. Welcome to Become a Good Problem Solver event organized by the GEM Foundation. In this event, we are going to see the solution for the senior math problem published on June 2026. Glad to share that this event has completed a year since the start from July 2025. The intent of this event is to share systematic approach of solving problems and sharing research proven techniques which children can apply to improve their comprehension, planning, and how they can systematically work on problems. So the art of problem solving can be kind of cultivated to all children by following a systematic framework called Cooper technique, which stands for understand, plan, execute, and reflect. There are many different ways that children can understand a problem, and some of the approaches that they can take is basically underlining the key terms, which gives the details, and also which also needs to be found out from the problem, and asking small guiding questions on how to approach the problem, what details are missing, and also they can slightly draw to visualize and understand the problem better. By making these visual drawings, it will help them comprehend the problem better and work on it. It will also help them identify some patterns and relationships in the given information and applying them to solve the problem. Now let's see what's the question is about for the senior problem. It's a very straightforward question. It says the rectangle shown has side lengths 8 centimeter and 4 centimeter. Find out the area of the shaded region. Can you spot a general observation based on the question asked? So they are asking for the area of the shaded region, and this is a rectangle with side length 8 and 4 centimeter. So this is the thing, and as you see here, this is the area that they have asked for. So what kind of questions children can ask to start with is, what is the shape of the shaded region? So the entire shape is a rectangle, but what is the shaded region? This looks like a right angle triangle, right? Because the angle in a rectangle is 90 degree inside a sides. So this is the area of a rectangle triangle. So as children might know, area of the triangle formula for it is half times base into height. So then comes the question how to find the area. We have written the formula. How to find the unknown values needed to find the area of the shaded region. But if you see here, you don't know the base, right? You don't know the base, but you know the height. Height is 4. Here again in the right hand side, you don't know the base, but you know the height. So when you know the height, you don't know the base, what you can do? How to find the unknown? So whenever you don't know about anything and you want to find how to work on it, you can apply the algebraic thinking. So algebra basically is a work with unknown variables, right? So how to apply algebra in this case? This is a very important thing that students might difficult to work with in the start, especially in such open questions. So in this case, you don't know what you don't know. I know this entire thing, which is 8, but I don't know just this part or this second part. So maybe what you can do is you can assign a variable for the length which is unknown. So if you can say this is x, the part on the left hand side, if this is x, can you also define the next part, a relation, or do you want to have it as a different variable y? So this is a very important thinking. So if you have the entire length as 8 and the first length as x, what could be the second length? Like if it is a and c and b, if you know AC is 8 and AB is x, how do you find the BC? Yes, so BC is nothing but 8 minus x. So the addition facts, multiplication facts are very important that you should be fluent enough to apply in such situations. So this is 8 minus x. So if you consider this as the first triangle and this as the second triangle, you can write the area of the first triangle is half times base is x and height is 4. So this would be 2 gets cancelled here. So this is 2x. And area of the second triangle will be, this is 8 minus x and then half times 8 minus x times 4. And here again get cancelled. So 2 times 8 minus x and then 2 times 8 is 16 minus 2x. So now what is the area of the total shaded region, which means first plus second triangles. So if you do that, you get 2x plus 16 minus 2x. And as you know, this 2x and minus 2x gets cancelled, they are 0. So this is 16 square centimeter. So the area of the shaded region will be 16 square centimeter. Now that was another interesting question which was asked. Can you spot any pattern? Because here the x can be anywhere, right? It can be like this, or the same rectangle. X can be here as well, right? With a very small x and a larger y or 8 minus x. So what can you say in this case? Think for a moment. So you are right. So exactly that x can be anywhere. So wherever the line can hit, it can also hit very long like this, right? Wherever it hits, the area of the shaded region will always be 16 square meter because the 2x and minus 2x gets cancelled. It's a generalization that we have applied. So it will be 16 square centimeter. And another interesting observation you can spot is what is the area of the rectangle itself? Area of the rectangle itself is B into H, which is 8 into 4, and that is 32 square centimeter. So as you can see, the area of the shaded region is how it is related to the area of the rectangle. It is half of it, 16 square centimeter. And curious students, those who are, you can actually check out having different rectangle dimensions and check is it really true that always this kind of shaded region, when you draw the shape, will it be half of the rectangle? And it would be really an exploration question if children started asking the same thing for different shapes. Yeah, I hope you all had a good understanding of algebraic thinking through this by working on this problem. Stay tuned for the next new event that will happen from July 2026, and looking forward to all your participation for the same. Thank you.